In this video, I will explain about common source amplifier with an ideal current source as load, how to find the gain of this circuit by using intuitive analysis, then finding the gain of this circuit using small signal model analysis, and then finally the voltage swing. By intuitive analysis, we know that the gain of this circuit is nothing but minus Gm times R out. Gm is nothing but Gm1 since Vn is applied to T1 and its source is grounded. So Gm will be equal to Gm1. Next is finding R out. R out is nothing but R out up parallel to R out down. What is R out up? That is nothing but the R out of the constant current source. What is a constant current source is one whose current is constant for any voltage value V. So the small signal output resistance of this will be equal to infinity, that is the slope of this line divided by inverse of the slope of this line. The slope gives I by V, that is the conductance. Inverse of that is nothing but the R out, that is equal to infinity. So R out up will be equal to infinity. R out down is nothing but the output resistance of T1 seen from drain, which will be equal to RDS1. So R out will be equal to RDS1 parallel to infinity, which will be equal to RDS1. So the gain of the circuit is given by minus Gm1 times RDS1. Next is the small signal model approach. Draw the small signal model of this circuit. For small signal model, short all DC voltage sources. So VDD is shorted to ground, and open the DC current source. So this source should be open. So here gate G1, source S1 is grounded. Vn is plotted between gate G1 and source S1. D1 is nothing but V out. Current through from D1 to S1 will be Gm1 times Vn. Then we have RDS1. The constant current source is nothing but an open or like equal to R equal to infinity. So we have this circuit. Find Gm. Gm can be found by shorting the output voltage. So short V out to ground, which results in I out equals to Gm1 times Vn. So Gm will be Gm1. And then find out R out by shorting Vn. When you short Vn, the voltage control current source will be open, which will result in RDS1. So R out will be equal to RDS1. So the gain of this circuit equals to minus Gm1 times RDS1. Voltage swing. Input voltage swing, that is what is the maximum and minimum value that the input voltage can take. Here we know that IRF is the constant current source. This current flows through transistor T1. So current through T1 is equals to IRF. And in saturation we know that IRF equals to beta naught by 2 W by L times VGS minus VTH the whole square. So for fixed value of IRF, we have one particular fixed value of VGS at saturation. So this circuit has only one fixed bias input voltage. which is not good. Any variation, that is Vn, if Vn is slightly above this fixed bias voltage, then the VGS is slightly above the required voltage. This results in a current higher than Iref, that is Iref plus delta I, or higher value. And with the higher bias voltage, the current T1 is higher, so the drain to source voltage tries to reduce, and this transistor might go to linear region, which is not good. Output voltage swing. Vout maximum value can go to VDD, since this is an ideal constant current source. Minimum value of Vout cannot go to ground because the transistor T1 has to be in saturation. So condition for saturation is VDS should be greater than VGS minus VTH. So Vout should be greater than VGS minus VTH, that is Vout should be greater than VGS1 effective. This is the condition for minimum value for Vout. Next is common source amplifier with a real current source. Previously I explained about the load being a constant current source. Replace this constant ideal current source by a current mirror current source. So this is a current mirror source which is shown here, this part, and this is connected to our NMOS, whose gate is provided with Vn, source is grounded, and drain is Vout. Let us see what is the gain of the circuit by intuitive analysis. Here we can just analyze the right hand side of the circuit, which is shown here. The gain of the circuit is nothing but minus Gm times R out. Gm will be equal to Gm1 because Vn is provided to T1 and source is grounded. R out is nothing but R out up parallel to R out down. What is R out? R out up is nothing but RDS2, that is the output resistance of T2 when seen from drain. R out down is will be equal to RDS1, that is the output resistance of T1 when seen from drain. So R out will be RDS1 parallel to RDS2. So gain of the circuit is nothing but minus Gm1 times RDS1 parallel RDS2. Let us find the gain of this circuit using the small signal model analysis. Draw the small signal model of the circuit, that is G1 connected to Vin, source S1 connected to ground. We have Gm1 times Vn from drain D1 to S1. We have RDS1 and drain D1 is nothing but Vout. Drain D1 equals to drain D2. We have to short the DC voltage sources here. VG23 is a constant voltage and VDD is a constant voltage, so we have to short this, that is gate G2 will be grounded, source S2 will be grounded. So here the voltage control current source will be an open, and we have RDS2 connected from Vout to ground. So flipping this circuit, we get this circuit where RDS2 will be in parallel with RDS1. Find out the GM of this circuit. GM of this circuit can be found by making Vout to be 0. So when Vout is shorted to ground, these resistors are shorted, the voltage controlled current source remains. So IOUT will be equal to GM1 times Vin. IOUT by Vn will be equal to GM1. So GM of this circuit is equals to GM1. Finding R out. To find R out, we need to short Vn, that is Vn has to be 0. If Vn is 0, the voltage control current source will be an open. So it results in Vout equals to IOUT times RDS1 parallel RDS2. So Vout by IOUT will be equal to RDS1 parallel RDS2. So Rout of this circuit is RDS1 parallel RDS2. The gain of this circuit will be equal to minus GM1 times RDS1 parallel RDS2. Next is the voltage swing. Input voltage range, that is Vn range. Here the current through T2 is fixed by VGS to 3. So we have a fixed current, that is I2. This current flows through T1 and it's a fixed current. So for a fixed current we have one particular fixed DC bias voltage for Vn, which is not good. Output voltage range. The output voltage Vout cannot go to a maximum value equals to VDD because the transistor T2 has to be in saturation. The condition for saturation here is T2, that is VDS2, should be greater than VDS2 minus VTH. Since this is a PMOS, we have to write VDS2 magnitude should be greater than or equal to VGS2 magnitude minus VTH. So VDS2 minimum value, that is magnitude, will be equal to VGS2 effective. So Vout maximum will be VDD minus the drop across T2, that is nothing but VDD minus VGS2 effective. Minimum value. Vout minimum cannot be ground or 0 since T1 has to be in saturation. Condition for saturation is VDS1 should be greater than VGS1 minus VTH. So Vout has to be greater than VGS1 effective. That is the condition for minimum value.